Okay, so I'm going to try and make a video here and run through problem 5.57 from the last homework, because I think that had an example of everything that we did, or that we need to do with this calculator. So when you start out and you've got this scratch pad, or you've got the first menu here, you can either do scratch pad or you can do new document. I've just been staying in the scratch pad. I think the only reason you would want to do different documents is if you wanted to have different settings stored, because each document has its own like number formats and everything else. So I'm going to calculate here. And then just to show you the settings that I've got, under document settings and status, document settings, here's where I'm at, and you may or may not want those. If you can't see those, I'm at float 12 for my display digits, degree for my angle, engineering for my exponential format, real or complex. I think that this one mattered for the vectors. You want to have it set to real. And then if you can see the rest of those, I don't know that they mattered, but that's what I use. So let's get back out of here. So let's look at an example of the problem here. So 5.57 first says to take the parameters from 5.14 and add compensation. So first of all, we wanted to find the impedance and reactance for the power line. And so if you can see here, our parameters were over here. We had our small z, our small y, our big z, and our big y. We want to find the zc, which was the square root of z over y. So I go on my calculator here, and I'm in degree mode up here at the top, and I just do square root of, and phasors always have to be in parentheses. So for my z over y, well actually let me take a step back. Okay, so if we want to convert from rectangular to polar, it can do it for us automatically. So in this case, our big Z is 15 plus, and I go down here for the special symbols, hit it twice to get I, 15 plus I, 175 ohms, and hit enter. And then I want to convert it to polar, so I go to the functions button over here, which we use a lot. And this is under the complex tools part. If I go to convert to polar, then it'll give me that. If I hit Control Enter, it'll give me the actual number, which in this case is 175.641 at an angle of 85 point yada 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 degrees. So that's my big Z is 175, and I'll just say 0.641 at an angle of 85.1 degrees. And my Y is just J 2.2 e to the negative 3, so that's just 2.2 e to the negative 3 at an angle of 90 degrees. Now if I want to find my ZC, I'll go ahead and I'll do square root of, and phasors always have to be in parentheses, so it's 175.641, control, and then this little symbol thing up here, and then find your degree. 85.1 was it? Yeah, I think it was 85. Yeah, 85.1 divided, whoops, go outside the parentheses, divided by parentheses, and we'll do our other one, 2.2 e negative 3 at an angle of 90. And I hit enter for that. That gives me my answer right there, and that's in rectangular. Now, again, I want that in polar, so I'm going to go to my book here, convert to polar, and that gives me 282.554 at an angle of negative 2.45 degrees. Alright, so I'm going to keep going here. We want to compute our gamma L. In this case, gamma is the square root, oops, I've already got up here, gamma is the square root of, our Z was 0.03 plus J 0.35, and our Y was just J 4.4 e to the negative 6. So I plug that right in just like that. And you can convert it to phasor first if you want, or you can just put it in rectangular. Then I'm going to multiply that by the length times 500. Now that gives me in rectangular. Again, I'm going to go down here, push my book button, convert to polar, and that gives me, that's e to the negative 3, so 0.621 and an angle of 87.55 degrees. Okay, 87.55 degrees. Now, to get my z prime, I need the cinch of this, right? So to do cinch, I go up here and I switch to radians, and then I just type in, I'm sure there's a button for it somewhere, but I just type in SINH, and I'm going to put it in double parentheses because it's a phasor, 0.621 at a angle of 87.55, and because I've switched my mode to radians, I'm going to go up here and I'm going to make sure that it knows that I mean degrees. So using this button here, degrees, and enter. That gives me my value. Now I'm going to convert that back to polar, but before I do that I have to make sure to remember to switch back to degrees. So now I'm in degrees, and I'm going to hit my book button, convert to polar, and my answer is, the cinch of that is 0.581 at an angle of 87.873 degrees. Okay, now multiply by my ZC, which I computed earlier as being, and I have to remember parentheses because it's a phasor, 282.441 at an angle of negative 2.5, and I don't have to put the degrees in because I'm not in radians anymore. It gives me in rectangular, convert it to polar again. This means my z prime is 164.379 at an angle of 85.373 degrees. Okay, now same thing for my line parameters. A and D were both hyperbolic cosine of gamma times L. So I'll just type in here, well, first I'll go back up here, switch to radians again. Excuse me. I'll say cosh of gamma times L, which was 0.621 at an angle, oops, wrong button, at an angle of 87.55, and I want to make sure that's degrees again, so I'll go back up to my symbols here, go back to degrees, enter, there's my thing. I want that in polar, so I'm going to go back up here, switch to degrees again, and hit my book, convert to polar, and now I see that that parameter is 0.814 at an angle of 1.086 degrees. Okay, so skim through all the rest. So we can see that the line parameters I've got down here, the rest of the math is just basically doing the same things. You know, take your hyperbolic sine, divide by your ZC to get your C. Anyways, you put this all together in the matrices like this, and I'll show you the matrix multiplication. So matrices are in this other button here next to the book. So, and these four, 1, 2, 3, 4 here, are your different matrices. This 3 by 3 actually will do any size. If you hit that one, you can put in the number of rows and columns you want. But we just want a 2 by 2, so I'm going to say in this 2 by 2, and my first matrix is 1 and negative j, 32.767, and then I had 0 and 1. That's the matrix for my first capacitor. I'm going to multiply that by my current line parameters. So I'm going to put in another 2 by 2 matrix here, and I'm going to, always in parentheses for phasors, 0.8135 at an angle of 1.09, and then my B was 109.338 at an angle of 85.33. Okay, then for the next parameter here, we come down to matrix element C, and that was in parentheses 0.002 at an angle of 90.8 0.239 degrees, and then our D parameter was 0.8135 at an angle of 1.09. So that's our second matrix finished. Now multiply by our third matrix for the capacitor at the other end. Up again, this button here, we're going to go to the 2x2 matrix, and that was 1 for element A, negative J, 32.767 for the B, 0 for C, and 1 for D. Now I just hit enter, and that puts it all together for me, and again it's in rectangular, so I can do the same thing I've done with everything else. I can go to the book and I can say convert to polar, and now it shows me a 0.879 at an angle of 1.026. Anyways, it's got this whole thing in matrix form, and you just kind of have to scroll back and forth to see the answer. So that's the matrices and the hyperbolics and the vectors. I think that was just about everything, so let me know if there was anything else that I can cover.